Hi everyone, welcome to Eve Math Tutoring. Today's lesson is on simplifying algebraic fractions. So let's start off with an easy example. So say you're asked to simplify something like this. So if you're given something like this, what you're going to do is see what you can cancel out from the top and the bottom. So it's kind of like simplifying regular fractions. So for the numbers, you just would do like you would with regular number examples. So 2 divides if I divide both the top and the bottom by 2, then I would get 1 over 3. So I could put the 3 here. And then the 2 b's would cancel, so I would be left with a. So I would just write it as a over 3 instead of writing the 1 there. Okay? So this 2 can cancel out here, and you're left with 3, or you could just think of the dividing the top and the bottom by 2. But really, I'm just canceling the 2 out with the 6, and I'm putting a 3, and then I'm canceling out the 2 b's, and then I'm left with a. Okay, so we can try some other examples. Say you have 12 m squared n times 15 mn squared, and you're asked to simplify. So if I divide both of these by 3, then I'm left with 4 over 5, and then this m can cancel one of these, and then this m can cancel one of those. So we'll be left with this. And then we would state that n does not equal to 0, because we can never have a situation where there's 0 on the bottom of the fraction, because that does not exist in math. Okay, so that would be the answer for that one. So let's try a few others. So say you had a minus b over b minus a. In this one, what I can do is maybe rewrite the bottom. I mean, it's the same thing, I'm just writing it in a different order. And then at that point, what I could do here is I could actually factor out the negative from a plus b. So when I factor out the negative, I'm actually dividing both of these by -1. So I'm factoring out -1. So when we have a 1, we don't really write it. But if I was factoring out a 2 or a number bigger than 1, I would have to write that in. So -1. So negative a gets divided by negative, which becomes positive a. And then positive b divided by negative becomes negative b. Okay, and at that point we see that we have the same thing here, and now we can just simplify this to -1 as our final answer. Okay, so a minus b, we can even put brackets here or not, but those cancel each other out and we're left with a negative, and we just put a 1. Okay, so that's how you would simplify something like that. So we can try some other examples. So let's try 2x minus y. So negative 2x minus y, y minus 2x. So the question is to simplify. So if I look at this, what I would probably do is move the negative up to the top. But when I do that, I have to change to the sign of both of those variables. And then on the bottom, I have y minus 2x. And then if I rearrange the top, now I get the same thing on the top and the bottom, so those cancel each other and just give me 1 as my final answer. Okay. We can do another example. So say we have a minus b, we want to simplify this algebraic fraction. What I'm going to do is see if I can get this bottom to be the same as this one. So I'm going to just rewrite the top for a second. And then if I so let's see here. Maybe if we pull out a negative from the bottom, then we'd be left with negative b plus a. So I'm factoring out a -1. And then if I rearrange this one here, it's actually the same as a minus b. So a minus b, c minus d, all over. I can rewrite this as a minus b. Okay, writing the a first and the b second. And at that point, I see that I can cancel these two out. So I'm left with negative bracket c minus a. And then when I bring the negative in, it comes into both terms, so it becomes negative c plus a. Okay, so that would be sorry, b, a, just a second, this is a d, this was a d. So that was actually c minus d, sorry about that. Okay, so yeah, so c minus d would be the final answer. Okay. So that's another example. We can do a few others. Let's try another one. So say you're asked to simplify something like this. What you want to do is see what you can factor out of the top first. So I can factor out an x. And on the bottom I can factor out an x too. And then those x's would cancel each other out. So then I'm left with 2x plus 1 over 3 as my final answer. And I can't reduce that any further. So that's how I know I'm done. Okay. Try a different example. AB plus BC over BC plus BD. So what can I factor out of these two? I can factor out a b, so I'm left with a plus c. And on the bottom, I can also factor out a b, and I'm left with, when I do that, I'm left with c plus d. Whenever you factor something out, you divide both of these by that variable that you're factoring out, or number, whatever you're factoring out. Okay, so now we can cancel out the b's. So then you're left with a plus c over c plus d. And then you would state that c plus d does not equal to 0, because you never want the denominator of a fraction to be equal to 0, because then it wouldn't exist. Okay? So that would be the answer there. I could do a few more examples. So say we want to simplify something like 7 over x squared minus 3x plus 2. So what you want to do is see if you can factor the denominator. So to factor something like this, I have to think of two numbers that add to -3 and multiply to 2. So the two numbers that would do that would be -2 and -1. So that means I could rewrite the bottom as x minus 2, x minus 1. And at that point I'm done. And at this point I could say that x does not equal 2 and x does not equal 1. So I can state the restrictions for my answer and for my fractions, because if x equals 2, then this would be 0. Or if x equals 1, this part would be 0. So if either of these were 0, that would make the whole denominator 0. Okay. So let's try another example. X plus y squared over x squared minus y squared. So this would be written as x plus y times x plus y. And the bottom is a difference of squares. It's x minus y, x plus y. Okay. So it's a difference of squares. So at that point, we can cancel those two, and we're left with x plus y over x minus y, and x does not equal to y. Because if it did, then the denominator would become 0. Okay? So that's another example. Okay, so we can try a few others. So you're asked to simplify something like x squared minus 4 over x cubed minus 8. So this here is a difference of squares, two numbers that add to add to 0 and multiply, because there's no middle term, nothing in front of x, so that's why we want two numbers that add to 0, and we want two numbers that multiply to -4, and those two numbers would be -2 and 2. Okay, and I know they have to add to 0 because if it wasn't 0, there would have been an x here in this situation. Okay, so now you're going to get x minus 2x plus 2. On the bottom, we've got a difference of cubes, and as you remember, so for a difference of squares, it's in the form a squared minus b squared, and it factors in this way. And then for a difference of cubes, I had done a previous video on both of these different topics. I've done separate videos on each one, but if you look at the video on the differences of cubes, you'll see that this factors in the following way: a minus b times a squared plus ab plus b squared. Okay, so this one here, if we look at it carefully, it's in the form x cubed minus 2 cubed, so that would factor as x minus 2, x squared plus 2x plus 4. Okay. Yeah, so because in this case, our A would be equal to X and our B would be equal to 3. Or, sorry, B would be equal to 2. Okay? So for this situation here. And then we would just plug them into this equation right here. That's how we got that. That's how I got this answer. Okay, so that's using the rule for factoring differences of cubes. You're just writing it in a different way. It's a factor form. Once you get into that form, you can now see if you've got anything common in the top and the bottom. And you do notice that these two cancel each other out. And then you want to, I would actually go further and see if I could factor this part further. So two numbers that add to 2 and multiply to 4, there are no two numbers that would do that. So because there's no two numbers that would add to 2 and multiply to 4, I can't factor this any further. So that's why I just leave it in my answer here. Okay, so that would be our final answer. So that's how you do a question like simplifying something in this form. Okay, so let's try another example here. Okay, actually there's one more example I want to show you. So it was something like this: 2x squared minus 5x minus 3 all over 4x squared minus 1. So for this one, again, you're using the rules of factoring trinomials where the number in front of the x squared is other than the number 1. So in that case, I want to look for two numbers that add to -5, the middle term, and multiply to 2 times -3. So multiply to -6. So two numbers that would add to -5 and multiply -6 would be the numbers -6 and +1. Okay, so what I'm going to do now is I'm going to replace the middle with those two numbers. So I'm going to go plus x minus 6x minus 3. So this is 1x minus 6x. So I replace these two, the middle, with these two. And if you want more practice on that, you can look at my video on factoring trinomials. Okay, and then the bottom here is a difference of squares. So it's this situation again. So and your situation that you've got here is you've got 2x squared minus 1 squared. Okay, so that would just factor in the form 2x minus 1, 2x plus 1. And actually, if you FOILed this thing back, you would end up with this answer. So that's how you would know that this is correct, okay? Or that those two are equal. So at this point now, we're going to see what we can factor out. Now we've got 4 items on the top, so what we're going to do is factor something common from the first two. And if I look at them carefully, I can factor out an x. I can divide these. The biggest thing I can divide out of both of these is an x. So I go ahead and do that. So 2x squared divided by x gives me 2x. Then x divided by itself gives me 1. Over here, the biggest thing I can factor out is a 3. So then I'm left with 2x plus 1 again. And then on the bottom, I've just got 2x minus 1, 2x plus 1. And then I notice this is common, so I can factor that out, 2x plus 1, x minus 3, divided by 2x minus 1, 2x plus 1. And then at this point, I see that these two would cancel, the 2x plus 1. So at that point, I'd be left with x minus 3 over 2x minus 1 as my final answer. And my restriction would be that x does not equal to 1/2, because that's what would make the denominator equal to 0. Okay, so that's how we would do that question. So that's a really good one to try out. Okay, so the question obviously would just ask you to simplify something like this. Okay, and that's how you would go ahead and do that. Okay. So let's try another example here. So you're asked to simplify something like x squared minus ax plus 2bx minus 2ab all over 2x squared plus ax minus 3a squared. Okay, for this thing again, what I do is I think of what can I factor from the top. And what I notice is I can take out an x from the first two, and I'm left with x minus a. And over here I can take out a 2b, and I'm left with x minus a again. On the bottom I've got the trinomial situation. I want two numbers that add to the middle term, which is 1, and multiply to 2 times negative 3, which is negative 6. So two numbers that add to 1 and multiply to negative 6 would be the numbers positive 3 and negative 2. So those add to 1 and multiply to negative 6. Okay, so what I do is I take this and I replace the middle with that, so I get negative 2ax plus 3ax minus 3a squared. So I replace this with those two. And if I actually simplified this, I'd still end up with ax, so I'm not actually changing the expression. At the top, I can factor out an x minus a, and when I do, I get x plus 2b. And on the bottom, I can factor out a 2x, and when I do, I get x minus a. And over here, I can factor out a 3a, and I get x minus a again. So on top, I get x minus a, x plus 2b. And over here I get x minus a, 2x plus 3a. Okay, and then these two cancel each other out. So then we're left with x plus 2b over 2x plus 3a. And then at that point you could say that x does not equal to negative 3 over 2a, because if it did, the denominator 2 times negative 3 over 2a would give us negative 3a, and negative 3a plus 3a would be equal to 0. So that's what you have to watch for. For your restrictions, you always want to state what would make the denominator equal to 0, and that's what you can't have your variables equaling. So x cannot equal negative 3 over 2a, because that would make this equal to 0, and also a cannot equal negative 2 over 3x. Right? Because if I did negative 2 over 3x, if I plugged that into a, the 3's would cancel out and I'd be left with negative 2x. And then 2x plus minus negative 2x would give 0 as well. So those would be your two restrictions on your denominators. Okay? So that's how to simplify algebraic fractions. So I tried to cover every type of example I could, and if you have any other questions, feel free to post them on the channel.